Okay, so we're talking about special triangles. We actually did this some in geometry. I know you guys probably forgot, so it's okay. One of the special triangles is a 45, 45, 90. Okay, if you have two equal angles, you guess what we know about these two legs? Okay, two equal angles happen when it's an isosceles triangle. So the two sides, the two legs, have to be the same. So it's a 1-to-1 ratio. Okay, it's a 1-to-1 ratio, and then the ratio of the hypotenuse is square root of 2 times that. Or you could call it 1 square root of 2. Okay, so that means, for example, if this was a 4 on a 45, 45, 90, what would this leg be? 4. The legs are the same, 1-to-1. That's what 1-to-1 ratio means. Okay, if this legs are the 4, if the legs are 4, what's the hypotenuse going to be? 4 times square root of 2, which does not simplify, so just goes like that. Okay, it's a little trickier if you start with the hypotenuse. Let's say, well, let me use something besides 4. Let's say it's 8. So if the hypotenuse is 8, how do I figure out the leg? So to go from leg to hypotenuse, you multiply by square root of 2. The hypotenuse is larger than the leg, right? So the hypotenuse is larger, so you should be multiplying by something. So if you're coming down from the hypotenuse to a leg, what do you think is going to happen? Divide by square root of 2. Now 8 divided by square root of 2, basically all you do, you can't leave square root on the bottom. Those don't reduce right there. But you multiply top and bottom by square root of 2, or you let your calculator do it. So it's 8 square root of 2 over square root of 2 times square root of 2 is 2. And in this case, the 8 and the 2 reduce. So this leg would be 4 square root of 2. And if this leg is 4 square root of 2, what's this leg? 4 square root of 2. Legs are the same in a 45, 45, 90. All right, and then the other special triangle. Do you guys kind of remember this a little bit?
I do.
It was like a year and a half ago. It was a long time. Well, a year and a quarter, maybe. The other special triangle we did was 60, 30, 90. They just show up a lot. So this one, we'll start with the easiest. The short leg, which is always across from the 30, is half as long as the hypotenuse, which is the longest side. So the ratio is 1 to 2. Means the hypotenuse is twice as big. Okay, the long leg is square root of 3 times the short leg. So you could say it's square root of 3 or 1 times square root of 3. Okay, so on these you want to run everything through the short leg. That's the easiest way to do it. So for example, if the short leg is, well, let's start with the hypotenuse. If the hypotenuse is 6, what's the short leg going to be? Right, half of that, so it's 3. If the short leg is 3, what's the long leg going to be? 3 times square root of 3, which does not simplify. So like that. And then they're going to do some SOHCAHTOA stuff with it too. So you guys still have the SOHCAHTOA notes? Or maybe you just got it in your head already. Got it in your head? All right. Okay. Number 1. Just fill in the missing parts here. Whoops. That was supposed to be a missing part. Have you guys seen this? You guys seen that before?
The Jesus fish?
Kind of. It's alpha. It's a Greek letter. I didn't draw it very neatly. Well, the Jesus fish is a Jesus fish because it's alpha. Alpha and omega represents Jesus. Anyway, but that's a Greek letter alpha. It's like a Greek A. I don't know why they used it, but they put it in that corner. Don't ask me why. It just is. Okay. So, there's three variables. We got to find out what they all are. So what would this angle for alpha be right here? 45. If it's 90 and 45, remember the three angles of a triangle have to add up to 180, right? So that only leaves 45 for this angle. Okay, so this one right here is one of the legs, right? So if this leg is 1 on a 45, 45, 90, what's this leg going to be? 1. Legs are the same. It's called an isosceles triangle. If the legs are 1, what's the hypotenuse? Yeah, 1 times square root of 2, which is just square root of 2. Okay, and then number 2 is the 30, 60, 90, right? So anyway. Did they surely drew this somewhere. Let me find it. Yeah, on page 439. They drew the two triangles out. Okay, number 3. So we're supposed to find sine, cosine, tangent of 30 degrees. So what I'm going to do is draw the 30, 60, 90. So we're using this 30-degree angle. So across from the 30, that's the short leg. That would be the 1. The hypotenuse on this one is twice as big. That's a 2. The long leg is square root of 3 times the short leg. So it's square root of 3. Okay. So they want sine of 30, cosine of 30, tangent of 30. It's kind of like yesterday's. Line the way.
Wait, what you even write it then?
Yeah, you guys don't have to write it. I guess if you just put it in the order that they wrote it, it's fine. You guys see where I'm looking, right? It's the table.
Yeah.
Sine of theta, theta is 30. So sine of 30. So, I don't know where we left off yesterday. Kyle wasn't with us. Let's do Caleb, then we'll come back around. We'll save Kyle for last. Caleb, what would sine of 30 be?
Sine of 30, opposite over hypotenuse.
Yeah.
So.
Oh, Kyle, you weren't really paying attention on Monday either. Do you remember SOHCAHTOA? Okay, you need to go back and do the other lesson, I guess. This might. Anyways, it's a review of something we did in geometry, but it's been a long time. Sorry, Caleb, what'd you say?
So opposite over hypotenuse.
Yes.
I'm confused. So is that 1 over 2?
Yes. Opposite of 30. Opposite of 30 is 1. The hypotenuse is 2. Huh?
Okay. Wait, just plug in sin, sine, or cos.
Yeah.
30.
Yeah. The problem is not all calculators do it, so I was just gonna go through. Okay, Caleb, what would cosine of 30 be?
Adjacent over hypotenuse, so that would be square root of 3 over 2.
Yeah. And tangent?
Opposite over adjacent, so 1 over square root of 3.
Right, but remember we can't leave the square root on the bottom, so if we multiply by square root of 3, it's square root of 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is 3. So it's square root of 3 over 3. Okay, and then we can kind of cheat with these other ones. Do you guys remember what was the reciprocal for sine? Yeah.
Is it the S?
Cos?
Yeah, it's
Right.
called cosecant.
Oh, that.
They kind of put it in order for us, right? If you look at it, cosine goes with secant, yuck, and then tangent goes with cotangent. So this is kind of like the last one from yesterday. Remember how we did it? We just
Split top 2 and do
so
reciprocal.
no. That is sine, cosine, tangent of the opposite angles. Okay, cosecant is just sine upside down. All of these are just, secant is cosine upside down, cotangent is tangent upside down. So we just gotta flip them upside down. It's like the last problem, not the most of the problem. So 1/2 becomes 2 over 1, 2. Square root of 3/2 becomes 2 over square root of 3, but
2 square root of 3 over 3.
right, 2 square root of 3/3. Might have to let your calculator fix it. Oh shoot, we just had this one. Remember it was 1 over square root of 3 before we fixed it?
Square root of 3.
So it's square root of 3 over 1,
Square.
square root of 3. Okay, and then really we're using the same picture. I'm gonna zoom out, because it just says sine of, we're using 60 degrees this time. Number 4 is using the 45-degree angle, so you have to use the other triangle, like from number 1. Okay, so let's see, Natalie, you haven't really done yesterday's, have you?
No,
Are you like, do you know what's happening right now?
a little bit.
Okay, well, we'll just go to Ava.
What? Good stuff.
Okay. Ava, what is sine of 60 gonna be?
Hang on, she's doing the evens.
No, I was writing it down.
Because you were doing the evens.
Okay, anyways, let's move on. Sine of 60 is,
That's opposite of our hypotenuse.
right, opposite of 60 degrees is,
Square root of 3 over 2.
right, Okay.
Cosine. Wait, am I doing that?
oh, you're doing all three. Cosine is,
Adjacent, so it would be 1/2.
right, adjacent over hypotenuse, so it's 1 over 2.
Opposite over adjacent, so square root of 3 over 1. So it would just be square root of 3.
Okay, and then what's the opposite of sine?
Yeah.
Cosecant is what it's called, cosecant. Opposite of cosine, secant. Opposite of tangent, cotangent. Okay, try and get these in your head.
No, I know the.
Okay, so all we have to do is flip them, but actually we kind of did this one earlier. Remember 2 square root of 3 over 2?
2
When you flip it, is that one.
square root.
Now this is kind of like the ones where the opposite angles switch. 1 over 2 flips to 2 over 1, so it's just 2. Square root of 3 flips to 1 over square root of 3, which is like,
3 square root of 3 over 3.
right. Can't leave the square root on the denominator.
So on 4, would it be this like the same numbers? As
No, 4 is a 45-degree angle, so you're using the other triangle, not the 30, 60, 90. 4 says 45 degrees, so you're using a 45-degree angle in a right
yeah, I
triangle.
know, but like.
So it's 1, 1, square root of 2.
Okay, so that's just what it is.
Yeah. What were you guys doing?
Simon something.
Signing something? Okay. This one is actually super easy, but we haven't done it in a long time. Like since last year. So I'm guessing we're not going to remember, but let's see if you got anybody does. Tangent of B equals 0.0378. Okay, so what we're supposed to do is figure out what, remember tangent, cosine, sine, you feed them angles, right? So B stands for some angle. And how do we figure out what this angle is if we know what it's equal to? Anybody remember? No? Okay. It is, so you're kind of going backwards, right? So it's called tangent inverse. Remember that button on your calculator?
Oh, yeah.
So you just do tangent inverse of the ratio and that'll spit out the angle. Like that. And does it tell us where to round it? 1/10 of a degree. What's the 10th place? Everybody got a calculator?
Yep.
What's the tenths place?
Is it right after the decimal?
That's not right.
What, is it 2 point, oh wait, hang on.
Oh, what did you put in? Oh, that's gone. Try again.
Here,
Did you do this one?
No, I'm trying to figure out, like,
Oh, I was looking at
what,
7.
what,
2
what
point-
on the calculator.
Yeah, it should,
2?
2.2 degrees.
Ow.
So it'd be a very tiny angle on this one, 2.2 degrees.
Yeah.
That's all you do, no problem.
Alright.
So what did, yeah, you had it right, Natalie. I just thought you were doing number 7.
Wait, on what? On 6? So we use, yeah. So you just put shift and then that and then you.
She had it. What's wrong?
I hate math.
It's mutual.
Hey, you're gonna have this key
I am okay. Yeah, let's go to 14. That sounds that feels right. Because that's kind of where the section ends. Number 9. All right. So we're kind of leaving, after number 8, we're leaving, well, actually after numbers 5, we're kind of leaving special triangles behind for a while. Number 9 is we're just finding the missing part of the triangle. We probably did this more this chapter than anything else because it's just very common. 6112. This is kind of how trig is used most often, I guess. All right. Let me back up and start over again. So, Kyle, do you remember this word last year? So, toa.
Do I remember it?
Yeah.
Indian word.
It does sound Indian, but it's just an acronym. It helps us remember like what the trig functions are equal to. So the S stands for sine, and what you do is you feed the sine an angle, and it spits out OH, opposite over hypotenuse.
What? Somebody shoot.
And then the C in the stands for cosine. You feed it an angle, and it's supposed to spit out adjacent over hypotenuse. This is on the video from yesterday. Oh, actually no, because we'd already talked about it on Monday, so I didn't like reteach. Darn.
Good job, Mr. Drew.
Okay, it's not on the video. And then tangent, you feed it an angle, and it's supposed to spit out OA, opposite over hypotenuse, or sorry, opposite over adjacent. Okay. So, Kyle, let's say this is angle A. So, what side do you think is opposite angle A? Opposite means like across from, okay, so it means far away. So this side over here would be opposite of angle A. On a right triangle, Kyle, do you remember what this side, the long side in a right triangle is called? It's across from the 90-degree angle, and it's also the longest. It's called the hypotenuse. Okay, the other side that's next to angle A but not the hypotenuse is called adjacent. Adjacent is a fancy word that means next to. Okay,
Listen.
that's if you're talking about angle A. But if you're talking about this other angle, I'll call it angle B. Now what's the opposite side? Shh. It's this one down here. For angle B, this is the opposite side because it's far away. This side right here for angle B is actually the adjacent side because it's next to it. And the hypotenuse is still the hypotenuse no matter what. Got it? All right. So what they want us to do is find x here. Okay, I'm back with you guys. Alright.
Okay, I'll pay attention now.
So what you do is you start with an angle, because remember all these functions you have to feed them. You have to feed an angle to them.
They're hungry.
They're hungry. So they take an angle and then they regurgitate a ratio, which could be a fraction or a decimal something. Okay, so relative to this angle, you need the side that you're looking for, and you need a side that we already know, because you can only have one variable to solve these. So relative to this angle, what's the side we know called? Opposite. What's the side we're looking for called? Hypotenuse. Which trig function deals with opposite and hypotenuse?
Squared plus squared.
Which trig function deals?
What were you saying?
She was saying Pythagorean theorem. That's not what we're doing. Sine. Which trig function uses opposite and hypotenuse?
Oh.
Sine. So we're going to use sine to solve this. So it's sine of the angle, which is 61 degrees, is supposed to equal the opposite over the hypotenuse. What's the opposite?
12.
12. The hypotenuse is x. Okay, this is just a tiny little equation that we have to solve for x. It's a little bit tricky because x is in the denominator. Okay, sine of 61 is just some number. It's some weird decimal that our calculators can tell us. Right now, I'm just going to leave it as is. Okay, if x is in the denominator, how can I get rid of it out of the denominator?
Multiply by 12.
No,
Oh.
multiply by x. It's kind of what we did last chapter. So when you multiply by x, that just goes away, right? But if you multiply that side by x, you have to multiply this side by x. Okay. You guys still with me?
Yeah.
I multiplied by x to get rid of it in the denominator over here. And now it's in the numerator on the other side.
Where did it go?
Nobody knows.
What the heck?
Oh, I just like touched the... Whoops.
Oh, well, you were there. Oh, there we go. Ashton. Come on now.
Okay, so I have x times sine of 61 equals this. So I just need to get rid of this. So how do I get...
Divide sine of x. Sine of 60.
Yes, divide by sine of 61. So that goes away. X is whatever 12 divided by sine of 61 is. In your calculator, you're going to need to close that parentheses or it'll say error. Probably. And we are still rounding to the 10th place, like this whole assignment. So it should be 13.7.
Oh, okay. Did that
Okay, let's recap what just happened, because this isn't as hard as we just kind of did it. If you see the pattern, then it's pretty quick.
Oh.
Okay, when x was in the denominator, I multiplied by x, that moved it up on this side. But then I divided by 61, sine of 61, that moved it down. So the x and the sine of 61 kind of exchanged places. So the answer was x equals 12 divided by sine of 61. You guys see the pattern?
Yeah.
Okay, so if I had, let's say, like cosine of 50 equals 20 over x, then x would equal 20 over cosine of 50. They just kind of change places. And that's what you put in the calculator. Okay, anyway, moving on. Number 11.
13%.
You guys kind of remember this from last year? Did you ever get good at it last year?
Maybe.
I don't know.
Get good. It was like it was the last test we took this and last year. I don't really remember how you did, but maybe I thought maybe you might. Okay,
Like the tier 1 geometry
No, there was just like those 2 chapters that didn't go well. The rest of you did pretty decent. Okay, but yeah, you like algebra more, I know. Okay, relative to this angle, so we need the side we're looking for and the side we already have. So what's this side called?
Opposite
Opposite?
over adjacent.
Adjacent.
Tangent.
Which trig function uses opposite and adjacent? Tangent. So it's tangent of the angle, 38 degrees, is supposed to equal opposite over adjacent.
And multiply by x over 5, so the x's cancel out. And then multiply.
Okay, yeah, did you not catch the pattern from last time? You multiply by x, that goes away, it comes up over here.
Yeah, that's
You
what I
divide
was
by
doing.
tangent. So these two just switch places. So x equals 5 over tangent of 38. What'd this come out as?
I got 6.4.
Yeah,
Yep.
6.4. Alright. This time, we know the sides, but we're missing the angle.
And then we go from there and do that.
Oh, good point, Ava, because we go from there and do that. Dude, that's what you said. You said go from there and do that.
Well, I know, like, you find the,
So vague.
you find the angle of it and then go and then do that one thing.
Dude, that's why.
Well, okay, I don't
Or
know.
that
What'd
one
you-
time did that one thing,
So we're looking for this angle.
Place.
and we went there.
We're gonna start by
That one thing.
kind of the same way as last time. The difference is this time the angle is the variable. But relative to this angle, we need 2 sides that we already know because we already have a variable here. So what are these 2 sides?
Opposite adjacent.
Opposite and adjacent. Relative to angle A, opposite and adjacent.
Tangent.
Right. So this time it's tangent of what?
X. No.
Well, yeah.
Oh.
I'll call it A because it's angle A. Tangent of A is supposed to equal
5 over 4.
opposite over adjacent. Okay, about 7 minutes ago we did a problem like
Oh,
this.
so it's tangent negative that.
Yes, it's called tangent inverse of 5/4. So this time it's spitting out an angle, a degree measurement.
Oh, I like this.
What'd it come out to?
51.3.
Jinx.
Nuh-uh. Maybe it's restroom.
Yeah.
But I want to get that problem first.
Yeah, we'll stop there.
Okay. Wait, why?
Alright, so 12, 13, 14 are like that.
Okay, so it's.
We'll finish this tomorrow.